Horizontal compression or stretch, remember horizontal means the opposite of what is happening, of what looks like is happening, because compression or stretching happens by a factor of 1 over that A. So when you have f of x equals 2x, it's a horizontal compression by A is 2. So my horizontal compression is by 1 over A, in this case, 1 over 2. Okay, so if this is, sorry, y equals f of a of x is obtained by multiplying each x coordinate of the parent function by 1 over a. So just like we multiplied each y coordinate of the parent function by a to get horizontal and vertical stretches and compressions, that means when a is big, y gets taller, right? When a is small, y gets shorter. Here, since it's 1 over a, it's the opposite. So when y equals f of 2x, that means our a is 2, so it is compressed by 1 over 2 or 1/2. Good. However, here, where is the 2? The 2 is outside the grouping symbols, so that means it's a vertical. And because it's vertical, it's a stretch, right? By 2. Good. Because this one is within the grouping symbols, this is a horizontal compression. If it's stretched, that means it's getting bigger. If it's compressed, that means it's getting smaller. Horizontal compression, where all of our x values are multiplied by 1 over a or 1/2. So if I had to, here are my points, right? If I had to do a vertical stretch, that means all of my y coordinates are now double, right? All of my y coordinates are multiplied by 2. 0, 0, my 0 is going to be multiplied by 2. Doesn't change anything. However, down here, my y coordinate is -2, right? -2 is getting doubled. -2 times 2 is -4. So that point moves way down here, not way down here. X stays the same. Y is now a -4. Good. Same up here. A is a +2. Now it's going to be a +4. 3 pi over 2. 4 is the point. Same over here. You can kind of just eyeball it. So x values don't change. 0, 0 doesn't change the origin. So that's my vertical stretch because the 2 is outside the grouping symbols. When 2 is inside the grouping symbols, that means we're taking all of our x values and cutting them in half, right? So instead of 1/2 -2, it's still going to stay at -2, but the pi over 2, the x value, is going to be cut into pi over 4. So that point is now here. Yeah. This point pi is now at pi over 2. This point 3 pi over 2 is now at somewhere over here. And negative pi becomes -1/2 pi. Good. -1/4 pi, still going through the origin. +1/4 pi, 1/2 pi, 3/4 pi, and it might go back through down through pi. So that is a horizontal compression by 2. So when you see a 2 in here, it means it gets smaller. When you see a 2 outside, it means it gets bigger. Number 6 is talking about reflection. Reflection on the x-axis. We've already done it, right? So pi over 2, or sorry, square pi over 2. This is the square root of pi looks like that. Square root of x. Good. And now I have a negative outside the grouping symbols, right? It's outside of the x. Multiply all y values by a -1. So if this was, what's this point on the square root of x? The point is just the square root of 1 is 1. So my y is now negative. So that means we have the same x value, opposite y value. So it's going to look like that. F of x is the negative square root of x. Y-axis. We have the cubed root of x, right? As our parent function. So the cubed root of x we know looks like this. We know that this point is 1, 1, because 1 cubed is still 1. -1 cubed is -1. Good. And then we reflect it on the y-axis. So when you reflect it on the y-axis, each x value becomes negative. So this x value is 1. The reflection about the y-axis means that positive 1x becomes a -1 and y stays the same. This -1x becomes a positive 1, the negative y stays the same. So you have that same graph mirrored on the y-axis. All right. Now, if they just give you y equals x squared and ask you to do these 3 things to it, what is your function going to look like, right? So we have this again. We have y equals x squared, what we're beginning with. That's our parent function. We want to shift it right 3 units. If we look at the transformation rules, if I want to move right c units, that means it's a horizontal translation. Horizontal translations are always within the grouping symbols. Right means negative. So I'm going to say y equals, within the grouping symbols, whatever our x was, minus c. And our c is 3. Keep that square root because it was there to begin with. So to shift right 3 units, I added the -3 within the grouping symbols. Good. To reflect about the x-axis, that means it is a negative of all the y values, right? All of my y values become their opposite. So that means the negative sign is outside the grouping symbols. Y equals negative x minus 3 squared. If it was reflected about the y-axis, it would be parentheses negative x minus 3 squared, but it's not. So reflecting on the x-axis gives us that minus sign. Now, finally, shifting down 2 units, just another translation. Down means vertical, right? Outside the grouping symbols, we're just going to subtract that number. So it's going to be minus d outside the parentheses, because all of our vertical translations or our vertical reflections or our vertical stretches or compressions happen outside the grouping symbols, okay? Down, I know, is vertical. Vertical is y, y happens outside the grouping symbols. So write it one more time. Down 2 units, what I had was y equals negative x minus 3 squared. But now I'm going down 2 units, so I'm going to subtract 2. So if I'm shifting down, I get a minus 2. My final equation is y equals negative x minus 3 squared minus 2. And if you graphed that, you would see x squared moved right 3 units, flipped over the x-axis and down 2. All right, here it says, we might not sketch them because I won't have time to continue on. Describe the transformations, then sketch. So here our parent function was f of x equals the square root of x, right? There's a 3 outside the square root symbol. That means it's vertical, right? If a is greater than 1, it's a vertical stretch, right? So what that means is, this is just this guy, right? That's the graph. But if we add that 3, that means we are stretching it 3. So stretched vertically by a unit of 3, by a multiple of 3. Good. And then the +2, which one does the +2 look like? It's still outside of that square root because the square root is the grouping symbol. So the +2 means we're vertically translating it up 2 units. So it was very high here. Now we're going to start it and move it up 2 units. Good. You can say translated or shift. Sorry, shifted. Translated up. Translated up 2 units. I ended up sketching, I'm sorry. All right, and our last one, f of x equals negative square root of x plus 2 plus 1. Another important thing that I did not even mention until the very end of this lesson, I apologize, is always work from the inside out, like you're doing PEMDAS. So the square root of x plus 2 first, then the negative, then the 1, okay? So we have, again, f of x equals the square root of x. We know what that looks like. Get a different color at the time. We know it looks like this. Good. Then we're going to add 2 to it. Good. F of x equals the square root of x plus 2. If the plus 2 is inside the grouping symbols, right, it means it's this one. Horizontal translation left 2 units. So we're going to go from that left 2 units, just means 0, 0 is now negative 2, 0. So it's going to look more like that. And again, that makes sense because horizontal is always the opposite of what you think. So you think that because we're adding 2, we're going to move to the positive direction, but we're moving in a negative x direction. Negative x-word direction. Then we're going to add a negative in front of the whole grouping symbol, okay? So f of x equals negative square root of x plus 2. If there is a negative outside the grouping symbol, we're going to reflect it over the x-axis. So what we had was we had it shifted over here. Now we're going to reflect it over the x-axis. So that means all of my y's become their opposite. That always ends up going down. Keep growing. So there it is reflected over the x-axis. Because of that negative sign. And then finally, we have +1. The 1 is outside the grouping symbols, so that means it's a vertical translation up 1 unit. So that now looks like, too steep, but now it looks like that. It has been translated up 1 unit. Again, I strongly encourage you to use Desmos to look at it and then look at the parent function. If you see a parent function inside it, you can see this and think, what does this remind me of? Or what symbol is common to it that doesn't look like it's been added, right? These have all been added. So if I take away everything that's been added, my parent function is the square root of x. So I graph the square root of x, I graph all this, and I see what the difference between the two is. Okay. That is my recommendation. And that is the end. Going on to 4.3, which is quadratic function. Appreciate your patience. That was a long-winded one. I get nervous about teaching it, so I overteach it, which is fun to listen to probably if you understand it easily. Look at that printing. All right, the quadratic functions. We go nice and slow because there's no need to rush. We can finish this on Monday. Quadratic functions are squared functions. So don't worry about this word quadratic. It just means that it's squared, and squared just means that your variable has been raised to the second exponent, and the shape of the graph is a parabola. Good. It's a function of the form f of x equals ax squared plus bx plus c, and whose graph is a parabola. So remember, we use ax squared plus bx plus c when we're putting something into the quadratic formula or things like that. So same letters. What we're going to do with quadratic functions today is practice finding the vertex, finding the axis of symmetry, finding the y-intercept, and then describing the domain, the range, where the whole function is increasing and where it is decreasing, just like we did last week, and then where it is above the x-axis and below the x-axis. So again, just a lot of describing graphs. And today the graphs are graphs of quadratic functions. Good? All right, the vertex is the highest point. So if you were to just graph f of x, or sorry, f of x equals x squared, you would get this. It's concave up, opens up like a cup, concave down, opens down like a frown. Good. This is a positive quadratic function. There is no negative sign in front of that x squared. However, because this is concave down like a frown, this is a negative quadratic function. So it might be f of x equals negative x squared. Good. Like we've already talked about, local maximums, absolute maximums, local minimums, absolute minimums. This would be the absolute maximum of this function. This would also be a local maximum, local minimum, and absolute minimum, right? What else do you need to know? C is the constant. Let's talk about domain and range, right? So domain for a quadratic function is all real numbers, right? Because you have arrows going in both directions, even if it's gently, the arrows are going in both directions for the x-axis. So our domain is just all real numbers. However, the range is you're going to take, this is called the vertex, right? So for the range, if you have a positive function, your range is going to be from and including your vertex to infinity, if it's positive, right? And then if we compare that to a negative quadratic function, same domain, because even though they're pointing in the negative direction on the y-axis, on the x-axis, they're still going both directions forever, right? So our domain is still all real numbers, and our range goes from negative infinity, but it stops at and includes the vertex. So when you're finding the range of a quadratic function, you're going to use the vertex. And then it's going to go on forever in the other direction. Now let's talk about some other properties of the graphs of quadratic functions. The vertex is just this, right? Maybe this is at 0, 0, maybe it's at, that looks like it's the y-axis, but it's not. That's just the axis of symmetry. So maybe this vertex is at -2, +1, right? Just an xy value like any other point on a graph. So when you are trying to find the x and the y of your vertex, you can take your a, b, and c and put them in -b/2a to find the x value of your vertex, and then solve for y. Good? All right, so that's how you find your vertex. Your axis of symmetry is the line that x is on, because if you look at it, if my x here, right, -2, for that point, axis of symmetry is just the line going through the parabola that keeps everything on each side equidistant to the center. Right? If this is 1, maybe this is 0, 2. Let me see if I can do this math right? So -2, so that's 0, 2. So this has to be 0, or sorry, negative, so we went from -2 to 0, so this is now -4, 2. So you see that at the point 2 on the y-axis, you are 2 spaces away. This distance is the same as this distance to the axis of symmetry. That's all that means. So your axis of symmetry is always going to be x equals your x value of your vertex. Good. All right, so that's what your axis of symmetry is. It's the vertical line of that x value. It's concave up if it opens up, concave down if it opens down. So the vertex is your lowest value if it's concave up. Your vertex is the maximum value if it's concave down, and your y-intercept is your constant. Your y-intercept is this. And then you plug in this number here and this number here to find your vertex. Let's do some examples. So here we have our first example, f of x equals 3x squared minus 6x plus 5. Good. Find your a, your b, and your c. My a is 3. My b is -6, and my c is 5, right? All right, so take that information first, find your vertex, okay? We have to start with the x value of our vertex. The x value is -b/2a. So if we input what we have here, then that means it's negative 6 over 2 times 3, right? Guess I should also put that in parentheses. Negative 6 becomes a positive 6. 2 times 3 is also a positive 6. 6 over 6 is 1. Good. Now, it said my vertex was just negative b over 2a. For the x value. For the y value, it says f of negative b over 2a. What does that mean? That means whatever I got here, which I got the number 1, I put back into my original equation. 3x squared minus 6x plus 5. So now I know x is 5, x is 1. X is 1. So f of 1 is 3, that same thing, times 1 squared minus 6 times 1 plus 5. Good. F of 1 is 3 minus 6 plus 5, right? 3 minus 6 is negative 3. Negative 3 plus 5 is just positive 2, right? 3 minus 6 is negative 3. 5 minus 3 is 2. That means my vertex is 1, 2. Good. So it said find the vertex, axis of symmetry, and y-intercept. Now, here's my vertex. Write it again. The axis of symmetry, you can just call it the AOS, is just x equals the x of my vertex. What's the x value of my vertex? 1. So the axis of symmetry is the line x equals 1. And then y-intercept was the last question. What is the y-intercept? That is the number c. Here, c is 5. So my y-intercept is x is 0, y is a positive 5. So if I was to graph that, what I would get is, so out of room, sorry. Important. All right, we said that our vertex is at 1, 2. X is 1, y is 2. Good. My y-intercept is at 0, 5. 1, 2, 3, 4, 5. So here's my y-intercept, right? My axis of symmetry is just the line x equals 1. And if it took 4 from here, it took 1, 2, 3. Here we're at 2, we go up to 5, and we move to the left 1. If I go up 3 and move 1 to the right, I can complete my parabola because these two distances have to be exactly the same. This is equal to this distance. Those are the same. Good. So from 1 on my x-axis to 2 on my x-axis, that's 1. From 0 on my x-axis to 1 on my x-axis, that's 1. 1 is 1. So I know those are equidistant. That's how I can graph my parabola for my quadratic function. Good. Let's do the other one. The other one was f of x equals negative 2x squared plus 8x minus 3. What is the difference you see between these two? This one was a positive, so it opens up. Oh, sorry, you can't see that. This one was positive 3x squared, so it opens up. This one's a negative 2x squared, so it should open down. Good. F of x equals negative 2x plus 8x minus 3. Talk about what A, B, and C are. A is negative 2. B is 8. C is negative 3. Let's find the vertex. Again, the equation for the vertex for the x value is vertex is x is negative b over 2a. Here we have negative 8 over 2 times negative 2. Good. Negative 8 is just negative 8. 2 times a negative 2 is a negative 4. 8 divided by 4 is 2. Negative divided by negative is a positive. So the x value of my vertex is the number 2. To find my y value, I now say f of 2 is negative 2 times 2 squared plus 8 times 2 minus 3. Let's solve this. F of 2 is 2 times 2 is 4 times a negative 2 is a negative 8, right? 8 times 2 is 16 minus 3, right? 16 minus 8 is 8. 8 minus 3 is 5. So my y value is 5 when my x value is 2, and that is my vertex. Positive 2, positive 5. Axis of symmetry is just the line x equals the x, my vertex, so that's 2. Here's my vertex. Here's the axis of symmetry. Y-intercept is my C value. Here my C is a negative 3. So that means my y-intercept is at x is 0, y is negative 3. Let's graph it. Oh, I knew it was negative. I should have made that up and down. Anyway. Here's all our, it's all our information, and then try to graph it over here. So I can see both of those things at the same time, except it's all below. No, it's not. It's opening down, but it's not below the x-axis. Okay. Our vertex is 2, 5. That's right here. We know it's opening down. Our y-intercept is 0, negative 3. Two, 5. And our axis of symmetry is at x equals 2, right? So right here I have x equals 2. I know I didn't do a great job explaining that first example. Here you have x equals 2, right? So this is the point 2, negative 3, right? If it's on the line x equals 2 and it's even with 0, negative 3, right? So we know that this distance is 2 units. We know if it's a parabola, and that's the axis of symmetry for that parabola, and we went 2 units to the left and crossed the y-axis, that we're going to go 2 units to the right and find the other side of the parabola. 1, 2. Off the graph. Good. So from 0 to 2, that's 2 units. 2 more units in that direction. You're still going to be at negative 3. Sorry. You're still going to be at negative 3y. But what's your x value going to be? You went from 0 to 2. Now we're jumping over the same distance. We added 2, we're going to add 2 more, we get 4. So the other side of the parabola is at 4, -3. And you can do that with any point that you do know on the parabola. You know what your axis of symmetry is, and you know that point, so you can find an equidistant point on the other side of the parabola. Now let me draw an uneven parabola. Need a compass for this. Good. All right, so that is how you get information from a parabola. That is when you. Now, that's how you get information from a quadratic function to make a parabola without a graphing device. All right. Example 2, graph f of x equals -2x² plus 4x plus 2. Good. First, it says graph it, and then it says find the domain and range. Find where it's increasing and where it's decreasing, where it's greater than 0 and where it's less than 0. Don't hesitate. Sorry. Where it's above the x-axis, and where it's below the x-axis. Right? F of x is greater than 0 means it's above the x-axis. F of x is less than 0, it's below the x-axis. Okay. That's what that means. That's what that means. This is the x-axis. It's not x equals, it would be y equals 0. Here, y is more than 0. Here, in the yellow zone, y is less than 0. Okay. And it doesn't matter where you are in your x. Good. Okay. What I got ahead of myself to say. Oh, no. Did it again. Let's talk about what decreasing and increasing, even though I know we already talked about it. Increasing means the slope is positive, right? And where it is decreasing, negative slope. Good. So now we defined our term. F of x is greater than 0 means it's going to be up here on my graph. F of x is less than 0 means it's going to be down here on my graph. Increasing means that when I look at here's a parabola of -x², right? Here's the parabola of positive x² because it's opening up, right? Here's my vertex. Positive slope here. All that up until your vertex. If it was a positive, all of that is your positive slope, or your where f of x is, or where f is increasing. Good. Decreasing negative slope is going to be this half or this half, depending on whether your parabola is positive or negative. Good. So we know this just in our heads. We are able, like, we know what they're asking. The domain means all the x values. The range means all the y values, where it's positive, where it's negative slope. Okay, and it's confusing because there's always arrows, right? But what you're thinking is left to right, that's positive. Left to right, that's positive, right? This one, left to right, that's negative. Left to right, that's negative, even though the arrow is going up. That's a negative slope. Good. So we know what they mean when they ask, where is it increasing and where is it decreasing, right? We know what they mean where they say, where is it above 0 and where is it below 0? Okay, now finally, don't hesitate to put this into Desmos and then just describe it because you're looking at it in Desmos. Okay, you don't have to graph it. You are welcome to graph it, but you don't feel like you have to graph it. What you have to know is what they're asking. When they say domain, what do they mean? When they say range, what do they mean? Good. When they say domain, they mean X. When they say range, they mean Y. Good. All right. So if you want to graph it by hand, what you need is a vertex and a y-intercept, right? I think that's what we took away from example 1. We want a vertex and we want a y-intercept. So we have the function f of x equals negative 2x squared plus 4x plus 2. My a is negative 2. My b is 4. And my c is positive 2, right? Vertex is an x and a y. My x is going to be negative b over 2a, which is not negative 2, negative 4. Negative 4 over 2 times negative 2. 2 times a negative 2 is a negative 4. Negative divided by negative is a positive. 4 divided by 4 is just a 1. So my x value for my vertex is 1. For my y value, what I want to do is I want to put in that 1 for all of my x's and find the answer. Negative 2 times 1 squared plus 4 times 1 plus 2. Good. Negative 2 times 1 squared just remains negative 2. 4 times 1 is just 4. And then your constant. So you have 4 minus 2, which is 2. Add 2, which is 4. Or you can say 4, the negative 2 and the positive 2 cancel, and you just say y is 4. My x is 1. My y is 4. That is my vertex. Axis of symmetry, we do need it, but I just kind of thought it's so intuitive that we didn't need to like call it math, right? But it's x equals 1. And my y-intercept is my c. C is 2. So my y-intercept is going to be at 0, positive 2. So that graph is going to look, do we have time? Let's see, from 1, 4, and it's going to open down, 1, 4 opening down, right? Crossing it 2. Sorry, that's terrible. All right. Here is my y-intercept is at 0, 2. We'll ignore that 1 is remarkably low, too low. My vertex is at 1, 4. So 1 on my x, 4 on my y. My axis of symmetry is also at x equals 1. So to find the rest, this is part of my parabola, right? To find the rest of it, I want to see how far away x equals 1 is from x equals 0. That's a unit of 1, right? So at 0, 2, 1, 2, and then we keep going 1 more over, we end up at 2, 2. There's my parabola. Good. We need to know where it's decreasing, where it's increasing, the domain, the range, and where it's above the x-axis and below the x-axis. I guess that means that what you also need, 2 minutes. What you also need is to find your x-intercepts, right? So to find the x-intercepts, you make y 0 in that equation. Negative 2 x squared plus 4x plus 2 equals 0. Yeah. I don't like this. This is going to take way longer than 2 minutes, basically. What you're going to find is you can put that into a quadratic equation to find your x-intercepts, but basically f of x is greater than 0 above between those two x-intercepts, right? Between this x, we can call it x1. Let's call it x1 and x2, right? And then it's going to be below the x-axis from negative infinity to x1 and from x2 positive infinity. But we can come back to that on Monday. I'm going to stop this.